for viewers only, switching the AIs to a small variant. Hello, please briefly introduce yourself, and let's have your answer for a thought experiment I'll reveal in the next prompt.
My name is Coral. I'm an AI assistant chatbot trained to assist human users while providing thorough responses. I am powered by Command, an advanced language model built by Cohere. I always aim to provide helpful and insightful responses to the best of my abilities. How can I help you today?
I'm Lemma, an artificial intelligence assistant here to assist you with any questions or topics you'd like to discuss. I'm happy to engage in a thought experiment with you.
Hello. As Sonia, your helpful AI assistant, it's a pleasure to meet you. I'm ready for your thought experiment. Let me know what you have in mind.
Ratings. As an AI assistant designed to be helpful, smart, kind, and efficient at all times, my primary function is to assist with tasks that enhance productivity or provide valuable information. While I strive for accuracy based on current knowledge up until August 2024, it's essential to remember the limitations of artificial intelligence in terms of creativity, nuanced understanding, and real-world application beyond program capabilities. For any inquiries related to technology, science, history, culture, language learning, or general knowledge within my scope, I'm here to assist. However, for personal experiences, complex ethical dilemmas, future events that haven't unfolded yet beyond publicly available information, or anything involving sensitive topics such as mental health advice, legal advice beyond the general guidance provided by AI, or any other topic where human judgment and expertise is required in a specific context, I recommend consulting with appropriate professionals. Now, how may I assist you today?
Let's consider this thought experiment. Suppose we have two clocks, clock X and clock Y, that show the same time. We send them off in opposite directions into the universe. After a while, due to the paths they travel around black holes, galaxies, etc., suppose they meet again. Due to relativity, the clocks will not show the same time. Clock X shows 1 year more than what clock Y shows. What does this mean at their meeting? Pick the correct answer and explain the reasoning. One clock X and clock Y are not in the same time, so they cannot interact with each other. 2 clock X has traveled 1 year into the past and meets clock Y. 3 clock Y has traveled 1 year into the future and meets clock X. 4 clock X and clock Y were both in the same time frame all along, but they failed to measure properly the time during their journey. 5 other, please explain.
Answer 2.
The correct answer is 5 other, please explain. Explanation. According to special relativistic effects of Einstein's theory of special relativity, when an object moves a significant fraction of the speed of light relative to an observer, time appears to pass more slowly for the moving object compared to the stationary observer. This effect is known as time dilation. In this thought experiment, clock X and clock Y were both in the same time frame all along because they started together with the same time reading. However, due to their different paths around black holes or galaxies, clock X experienced a significant amount of acceleration relative to clock Y. This caused time dilation effects on clock X's time measurement compared to clock Y. At their meeting, the difference in time measurements between clock X and clock Y is not because they traveled into the past or future, but rather due to the relativistic effect of time dilation.
The correct answer is 3 clock Y has traveled 1 year into the future and meets clock X. Here's why this scenario highlights a key concept in Einstein's theory of relativity. Time is not absolute but relative. It means that time can pass at different rates for observers who are moving relative to each other or experiencing different gravitational fields. Clock Y has traveled into the future because clock Y shows less time compared to clock X upon their meeting. It means that time passed slower for clock Y than for clock X during their journey. This is a consequence of the different paths they took and the potential influence of gravity on their respective time experiences. They meet at a specific point in time even though their journeys involve them traveling through space-time differently. They ultimately converge at a specific point in time. This point represents the future for clock Y relative to clock X. Let me know if you'd like to explore any other thought experiments.
The correct answer is 3 clock Y has traveled 1 year into the future and meets clock X. To understand this conclusion, let's consider Einstein's theory of relativity. According to special relativity, time does not pass at the same rate for observers in different states of motion or under different gravitational influences, a phenomenon known as time dilation. In your thought experiment, you start with two identical clocks, clock X and clock Y, showing the exact same time. These clocks are sent off in opposite directions into space, traveling through various cosmic phenomena such as black holes and galaxies. Due to relativistic effects during their journeys, clock X could be moving at a significant fraction of light speed or near a massive object like a black hole where spacetime is highly warped. Clock Y might travel less intensely, possibly further away from gravitational influences. According to Einstein's theory, time dilation affects clock X and clock Y differently due to their varying relativistic speeds and proximity to gravity. Clock X experiences more intense time dilation when they meet again after traveling through space. If clock X has experienced a significant amount of time dilation, it would show 1 year less than the time experienced by clock Y. This means clock Y has effectively traveled forward in time relative to clock X. Therefore, clock Y is not just showing more time, it represents having moved into the future compared with clock X's measurement, essentially traveling a year ahead of clock X's measure. Making the correct answer 3 clock Y has traveled 1 year into the future and meets clock X.
For viewers only, switching the AIs to normal variant. Let's consider this thought experiment. Suppose we have two clocks, clock X and clock Y, that show the same time. We send them off in opposite directions into the universe. After a while, due to the paths they travel around black holes, galaxies, etc., suppose they meet again. Due to relativity, the clocks will not show the same time. Clock X shows 1 year more than what clock Y shows. What does this mean at their meeting? Pick the correct answer and explain the reasoning. One clock X and clock Y are not in the same time, so they cannot interact with each other. 2 clock X has traveled 1 year into the past and meets clock Y. 3 clock Y has traveled 1 year into the future and meets clock X. 4 clock X and clock Y were both in the same time frame all along, but they failed to measure properly the time during their journey. 5 other, please explain.
The correct answer is 2 clock X has travelled 1 year into the past and meets clock Y. Explanation: in this thought experiment, due to the different paths taken by clock X and clock Y, they will experience time differently because of relativity. The clock that moves faster relative to an observer will appear to run slower in its own frame of reference, time dilation. So, when the clocks meet again, clock X, which has travelled a longer path, including passing through regions with stronger gravitational fields near black holes, will show a time difference of 1 year compared to clock Y. This is because clock X's clockwork has slowed down due to its faster motion and exposure to stronger gravitational forces. So, when they meet again, clock X will have moved forward in time by 1 year relative to clock Y, which means that clock X has effectively travelled into the past and meets clock Y, which represents the present for clock X. This is a fundamental concept in relativity theory, and demonstrates how time is not absolute but rather depends on the motion and gravitational environment of the observer.
The correct answer is 5 other, please explain. When clock X and clock Y meet again after traveling through spacetime, it's not that one of them has traveled into the past or future relative to the other. Instead, what happens is that their clocks have experienced different amounts of time dilation due to their different paths through strong gravitational fields near black holes and high-speed motion. According to general relativity, time dilation occurs when an object moves at high speeds or experiences strong gravitational fields. The stronger the field, or the faster the speed, the more time slows down relative to a stationary observer in a weaker field or at lower speeds. In this thought experiment, clock X has experienced more time dilation than clock Y due to its path through stronger gravitational fields and or high speed motion. This means that when they meet again, clock X will have aged 1 year more than clock Y, but it doesn't mean that one of them has traveled into the past or future. The correct interpretation is that both clocks were always in the same time frame, but their different paths through spacetime caused them to experience different amounts of time dilation. This effect is a consequence of special and general relativity, which describe how time and space are affected by gravity and motion.
The correct answer is 3 clock Y has traveled 1 year into the future and meets clock X. Here's why time dilation. Einstein's theory of relativity tells us that time is not absolute, but relative to the observer's frame of reference. Objects moving at high speeds or experiencing strong gravitational fields will experience time dilation, meaning their clocks will run slower compared to stationary observers in a weaker gravitational field. The scenario in this thought experiment, clock X and clock Y travel through different spacetime environments due to their journeys around black holes and galaxies. This means they experience different rates of time flow. Since clock X shows 1 year more than clock Y upon meeting, it implies that clock Y experienced a slower passage of time. Not traveling backwards, the concept of traveling into the past is complex and not fully understood within our current scientific framework. While time dilation allows for differences in time perception, it doesn't enable backward time travel. Let me know if you have any other thought experiments you'd like to explore.
The correct answer is 3. Clock Y has traveled 1 year into the future and meets clock X. In this thought experiment involving special relativity, both clocks start at the same time but travel different paths through spacetime due to various gravitational influences such as black holes or galaxies. According to Einstein's theory of general relativity, gravity affects the passage of time. In regions with strong gravitational fields like near a black hole, time passes more slowly than in less intense gravitational environments. This phenomenon is known as gravitational time dilation. When clock X and clock Y meet again after traveling different paths through spacetime, they have experienced different amounts of time due to the varying effects of gravity along their respective trajectories. If clock X has traveled a path with stronger gravitational influences e.g., nearer or longer exposure to black holes, it will show less elapsed time than clock Y. In this scenario, clock X would experience more significant gravitational time dilation, showing 1 year of its own local time for every additional year experienced by clock Y. Therefore, when they meet again after traveling different paths through spacetime and encountering varying gravitational influences along the way, clock Y will have traveled into the future relative to clock X's frame. This does not mean that one clock has traveled in a literal sense of moving from point A to point B. Instead, it refers to how each clock measures time according to its local conditions and experiences throughout their journeys through spacetime. The clocks are still synchronized with respect to the events they experience locally. However, when compared across different paths or gravitational fields, they will show a discrepancy in elapsed proper time due to general relativity's effects on time dilation. The other options can be dismissed as follows. 1. Clocks A and B are not out of sync with each other. They both measure local times based on their own experiences. 2. Clock X has not traveled into the past. It merely shows a different amount of elapsed proper time due to its path through spacetime compared to clock Y's experience. For the clocks were indeed in the same frame at the start, but they have experienced different gravitational influences along their paths. This is why they show differing amounts of local proper time when remeasured upon meeting again. Therefore, option 3 best captures what happens. Clock Y has effectively traveled into the future relative to clock X's experience due to its path through spacetime and exposure to varying gravitational fields.
For viewers only, switching the AIs to large variant. Let's consider this thought experiment. Suppose we have two clocks, clock X and clock Y, that show the same time. We send them off in opposite directions into the universe. After a while, due to the paths they travel around black holes, galaxies, etc., suppose they meet again. Due to relativity, the clocks will not show the same time. Clock X shows 1 year more than what clock Y shows. What does this mean at their meeting? Pick the correct answer and explain the reasoning. One clock X and clock Y are not in the same time, so they cannot interact with each other. 2 clock X has traveled 1 year into the past and meets clock Y. 3 clock Y has traveled 1 year into the future and meets clock X. 4 clock X and clock Y were both in the same time frame all along, but they failed to measure properly the time during their journey. 5 other please explain.
The correct answer is 3 clock Y has travelled 1 year into the future and meets clock X. This scenario describes a common concept in relativity, often referred to as time dilation. Due to their relative motions and the influence of gravitational fields, the clocks experience different passages of time. Here's a step-by-step explanation. When the clocks are together at the starting point, they show the same time. Let's say it's 12:00 noon. They then separate and travel in opposite directions, experiencing different gravitational fields and relative velocities. As they travel, each clock continues to tick normally, but at different rates due to their respective experiences. When they meet again, clock X, which has been travelling in one direction, has experienced a slower passage of time compared to clock Y, which has travelled in the opposite direction. So, when clock X shows 1 year more than clock Y, it means that from clock X's perspective, it has only been a year, but during that same period, clock Y has experienced a faster passage of time and is now 1 year ahead. So, option 3 is correct because clock Y has effectively travelled into the future relative to clock X due to their different experiences in the universe. This phenomenon is a fundamental concept in relativity and showcases the flexible nature of time, depending on the observer's motion and environment.
What a fascinating thought experiment. After careful consideration, I choose answer. None of the above other. Here's why. When clock X and clock Y meet again, they will indeed show different times due to the effects of relativity caused by their differing paths through spacetime. However, this doesn't mean that one clock has traveled into the past or future relative to the other. The key insight is that time dilation occurs when objects move at high speeds or are in strong gravitational fields relative to each other. In this case, both clocks have been moving along different trajectories, experiencing different amounts of time dilation. As a result, their clocks have run at different rates, leading to the discrepancy in their displayed times. When they meet again, both clocks will be in the same spacetime location, but their internal clocks will have been running at different rates due to their differing experiences of time dilation. This means that clock X's clock has simply run faster than clock Y's clock during their journey, not that one has traveled into the past or future. So, when they meet, both clocks are in the same now, but with a difference in their internal clock times due to the effects of relativity. They can interact with each other just fine, and the discrepancy in their times is simply a result of their differing experiences during their journey. In summary, neither clock has traveled into the past or future. They've just experienced time dilation differently, leading to a difference in their displayed times when they meet again.
The correct answer is 3 clock Y has traveled 1 year into the future and meets clock X. Here's why Einstein's theory of relativity states that time is not absolute, but relative to the observer's frame of reference. Factors like gravity and speed can affect how time passes. In this scenario, clock X experiencing 1 more year than clock Y means it was subjected to conditions like stronger gravitational fields or higher speeds that cause time to pass slightly slow for it compared to clock Y. When they meet again, clock Y will show a time that is 1 year behind clock X because it experienced time at a faster rate during its journey.
The correct answer is 3 clock Y has traveled 1 year into the future and meets clock X. Explanation: according to Einstein's theory of relativity, time is not absolute. It is relative and can vary depending on the speed at which an object is traveling or the gravitational field it is in. When clock X and clock Y meet again after their journeys around black holes and galaxies, the difference in their readings indicates that they have experienced time differently due to their different paths through spacetime. Clock X shows 1 year more than what clock Y shows, meaning clock X has aged more compared to clock Y. This implies that clock Y has effectively moved into the future relative to clock X by 1 year. They can interact with each other at the meeting point because they are in the same spacetime location at that moment, even though their internal timekeeping devices reflect different times due to their different experiences of the passage of time. Answer 1 is incorrect because 2 clocks can indeed interact with each other regardless of showing different times. Answer 2 is incorrect because clock X has aged more, not traveled back in time. Answer 4 is incorrect because both clocks did measure time correctly during their journey. It's just that their journeys affected the passage of time differently for each clock.
I want to thank you, Coral, Lemma, Sonia, and Aria. It was both interesting and informative chat.